ये first question is a spool of mass m and moment of inertia about centroidal axis IC 3 mr square over 2 is released from rest as shown in the figure. Tension in this string is. In this question you have to find out the tension in this string. So if you see, motion here is Crtm, right? Look at the second question. A uniform rod of mass m and length L is suspended with the help of two strings A and B as shown in the figure. If the string B is cut, then the tension in string A just after the string B is cut is equals to this, where P and Q are co-prime integers. Find the value of P plus Q. So look at here, we are going to cut the string B. So if you are going to cut the string B, it's going to rotate because center of mass of the rod is here. So it's going to rotate, angle is going to be change of this rod from initial, and also center of mass going to move. So you will see here motion will be again combined translational plus rotational, that means CRT, right? Look at the third question. A uniform rod of mass m and length L is lying at rest on a smooth horizontal surface. A particle of mass m moving with velocity v0 hits the rod perpendicularly at one end and sticks to it. How long does the rod take to rotate through an angle of 90 degrees? Again you'll see, when this particle is going to stick at one end, center of mass of the system will be somewhere here, and you'll see the center of mass going to move as well as this rod is going to rotate, right? So you see here motion is again what? CRTM, right? Translational plus rotational. So if we take a quick recap of CRTM, So if you remember what we have talked, CRTM means translational motion of center of mass, and plus rotational motion about center of mass, right? In translational motion, what we have to do? We have to replace the body, right? Replace the body with point object at center of mass, and so forces with their directions, right? So you have to replace the body with a point mass at center of mass, and so all the forces with their directions. And for rotational motion, what you can do? You can fix the body about an axis passing through center of mass, right? Now in CRTM, if we talk in CRTM, if you remember, we have talked, if F external on the system is 0, that means P system will be conserved, right? And external torque on the system is 0, then angular momentum of the system will be conserved, right? Second, if force and torque both are present, torque are present, you have to write force equation or equations, right? For translational motion, torque equation or equations for rotational motion, and third, constant relation between them, right? Constant relations, you will get one or more than one, so constant relation or relations between them, right? Let's take this question. A spool of mass m and moment of inertia about centroidal axis IC 3 m²/2 is released from rest as shown in figure. Tension in the string. We have to find out the tension in this string, right? So see, if you are going to release it from rest, it's going to be downward, rotating clockwise, right? So center of mass is moving, right? Center of mass is going to move downward, so acceleration A, and it's rotating clockwise, so alpha clockwise. Now you know this motion is Crtm, right? So Crtm, translational motion plus rotational motion. So if we think about translational motion, so we have to replace the body with a point object at center of mass and see how many forces acting on it. Tension force upward, mg downward, right? And acceleration downward because it's going to move downward, right? So we can write the force equation. What will be the force equation? Mg minus T equals Ma, right? This is the equation 1. And if we talk about rotational motion, so see, this tension force is acting here, so, and mg is acting here, so about the center, torque of mg will be 0 and torque of the tension will be, you see, perpendicular distance is r, so torque of the tension will be T, right? And I alpha, we can say, we are writing here tau c equals IC alpha, right? So torque of this TR, we have the torque TR, and IC we have given 3 mr²/2 and alpha. So see what we got here, we got tension equals 3 mr alpha/2. Third, we can think of constant relation. You see, we have 3 unknowns like tension, acceleration A, and angular acceleration alpha, right? So now we can think about constant relation. You see, if we think about 2 points, one at a spool and one is the end of this string, one of the end of the string. So this end of the string is inextensible, so it will be at rest, and If we talk about the spool point, it has the downward acceleration a and upward acceleration from the angular alpha r. So net acceleration will be a minus alpha r, and that's supposed to be 0. So third, we can write the constraint relation, right? So if we talk about constraint relation, so you see we can write a minus alpha r equals 0. We have to always write the constant relation. We have to check the constant relation. We cannot directly write a equals alpha r because it can be different. So we got the a equals alpha r. So now we have 3 equations and 3 unknowns we can solve. Mg minus t equals ma we have, and we can put here in the second equation. You see we can put r alpha as a, so we will get 3ma over 2, right? And we need t. So in the first equation, what we can do, we can keep the t and we can replace the ma, that is 2t over 3. And if we'll solve this, you see what we'll get, 5t over 3, right? So from here we got t 3 mg over 5, right?